Hi, grade 11C. Today we will talk about atomic structure. Okay? In this chapter, we are going to have an idea about the hypotheses and theories of the scientists about the structure of the atom. Number one, the early history of the chemistry. The Greek philosophers proposed that the matter is composed of a small, indivisible particle called the atom. Okay? Aristotle refused this idea of the atom and had proposed that all matter was composed of four fundamental substances. Okay? They are fire, earth, water, and air. But in 1661, the Irish scientist Boyle reviewed the concept of Aristotle and gave the first definition of the element. What's meant by element? Element means the substance which can be further divided into simpler substance by the chemical method. In 1803, the English scientist Dalton put forward the atomic theory, known at this time as a Dalton's atomic theory. What is a Dalton's atomic theory? Dalton's hypothesis that, number one, each element is made of tiny indivisible particles called atoms. The atoms of given element are identical. Okay? Number three, the atoms of different element are different in some fundamental way. Again, in Dalton's atomic theory, Dalton told us each element is made of tiny particles, okay, called atoms. So the atom is considered a building unit of the element, or the fundamental building unit of the element. Number two, the atoms of given element are identical. That means the atoms contribute. The structure of the element must be similar. Okay. Number three, but the atoms of different elements are different in some fundamental way. After that, the scientists discover a cathode rays, which help many scientists to discover the accurate structure of the atom. Okay, and the English scientist Rutherford made a very important experiment called Rutherford's cold foil experiment. In this experiment, Rutherford used a radioactive source, okay, which radiated beam of alpha particles, and these beams received on a gold foil surrounded by detector. Okay, Rutherford observed that some of alpha particles beams rays go in a straight line, and some of them are deflect. Okay, and the other are reflect. Okay, and Rutherford began to explain his observation. Number one, most of alpha particles travel through the foil undeflected. Means, okay, most of alpha particles travel in a straight line, okay, through the gold foil. The explanation: the atom is mostly empty space. Okay, that's explain that the atom, the model of atom, is mostly empty space. The observation number two: some alpha particles are deflected by small angles. Okay, and this means that the nucleus is positively charged, as is the alpha particles. So they cause the alpha particles deflection. The observation number three, okay, occasionally an alpha particle travel back from the foil. That's mean the alpha particle mean reflected back. That's mean the nucleus carries most of the atom's mass. So, after Rutherford experiments, Rutherford, okay, can make a very important model for atom. Okay, Rutherford told us The atom, it looks like the sun, around which electrons, okay, orbits. Like the sun, around the sun, planets are revolving. Number 2, the nucleus. The nucleus is much smaller than atom and contain a vast space. Okay, there is a vast space between nucleus and the orbits of the electron. Number 3, most of atomic mass is positive charged are concentrated in the nucleus. Okay, the electrons, they have negligible mass compared with that of the nucleus, and the number of negative electrons revolve around the nucleus equal the number of positive proton, okay, that found inside the nucleus. So the atom is electrically neutral. Okay, again, Rutherford model of atomic structure is very important model because he can describe by easier way the composition and the structure of the atom. Okay, again, I will repeat again. Rutherford told us, number 1, the atom looks like the sun, around which electrons, like a planet's orbit. The atom contains a central core called the nucleus. Okay, the nucleus much smaller than atom, but there is a vast space between nucleus and the orbits of electrons, and the most of atomic mass and positive charge are concentrated in the nucleus. Okay, so the mass of the atom is concentrated inside the nucleus. Number 3, the electrons have negligible mass compared with the positive protons found in the nucleus. Okay, and the number of negative electrons equal the number of positive protons, so the atomic is electrically neutral because the positive charge inside the nucleus equal the negative charge. Number 4, electrons never fall inside the nucleus due to 2 forces equal in quantity and opposite in direction, attraction force and the centrifugal force. Okay, atomic emission spectrum. Okay, yes, in this slide, okay, we note that the major portion of the atomic mass is concentrated in the minute, centrally located, positively charged nucleus. Okay, Rutherford predicted the presence of particles with the unit mass but having no charge, as he named such particles neutrons. So Rutherford told us very important information about atomic structure. Okay, we have 3 particles inside the atoms. Okay, positive particles called the protons, negative particles revolve around the nucleus called electrons, and neutral particles called the neutrons. Rutherford, okay, developed the model of the atomic structure, okay, and make the experiment Rutherford called Foil experiment, which can imagine the atomic structure. Atomic emission spectra. What's meant by line spectrum? Line spectrum means a group of colored lines produced on heating gases or vapor of the substance to high temperature under low pressure. Line spectrum is a specific property for element, so each element has a specific spectrum. okay, because there is no two elements have the same line spectrum, and it look like a fingerprint in humans. Nearly in 1917, the scientist Bohr, okay, made atomic theory. Bohr's atomic theory retains the same postulated of Rutherford's atomic theory. Okay, Bohr made the following postulated, which are: number one, at normal conditions, the electrons orbit the nucleus in a rapid movement without emission or absorption of any amount of energy. Okay, electrons orbit the nucleus in a definite allowed energy levels and can't be found in intermediate distance. Each electron in the atom has a definite amount of energy depending on the distance between its energy level and the nucleus. The energy of any level increases as the radius increases. Number four, each energy level is expressed by a whole number called the principal quantum number. We have 7 energy levels in heaviest atom, okay? The first energy level, it's a symbol K, okay? And the principal quantum number equal 1. The second one, symbol L, and the principal quantum number 2. The third level, it's a symbol M, okay, and the principal quantum number equal 3. The fourth is level called N, and principal quantum number equal 4. The fifth, symbol O, and the principal quantum number equal 5. Sixth symbol equal P, okay, and the principal quantum number equal 6. The seventh level, it's a symbol Q, and the principal quantum number equal 7. Okay. Bohr was found that the maximum number of energy levels in the heaviest non-atom in this time, okay, in their ground state is 7. Okay, the electron remain in the lowest allowed energy in its ground state. However, if it gain an amount of energy, okay, means quantum, the electron become excited and jump temporarily to a higher energy level depending on absorbed quantum. And when the electron during a chemical reaction lose the quantum of energy, it returning back to its level, normal level, and the atom in this case return back to ground state. Okay, again, every electrons have an amount of energy, allow it to found in the energy level have a same amount of energy. Okay, the electrons can't transfer from level to higher energy level, like electron can't transfer from K level to L level, okay, if it except the electron gain an amount of energy called the quantum. In this case, when the electron gain an amount of energy, it can transfer from K level to L level, okay, and in this case, the atom become excited, not stable, okay. After that, when the electron lose a quantum of energy, okay, so it returning back, okay, to its level, normal level, and the atom retain or returning back to its ground state, okay. We have important note. The excited electron in the higher energy level is unstable and soon returns to its original level, losing the same quantum of energy which absorbed it. This picture in front of you, okay, explain the Rutherford's gold foil experiment. Number 1, quantum. What's meant by quantum? Quantum means the amount of energy absorbed or emitted by electron when the electron jumps from one energy level to another. The quantum of energy required to transfer one electron from one energy level to another is not equal because the difference in energy between them is not equal, because there are a big difference between energy levels. The electrons doesn't move from its energy level to another unless the energy absorbed or emitted is equal to energy difference between two levels. Okay? Like one quantum. Okay? Bohr's atomic model has advantages, okay, and also has disadvantages. First, we will talk about the advantages of Bohr's atomic model. Bohr succeeded in explaining the hydrogen atom spectrum, okay, and introduced the idea of quantum energy state for electron in the atom, okay, which means that each electron has a definite amount of energy. But the model of Bohr has disadvantages, okay? Like what? Like, number 1, Bohr failed to explain the spectrum of any element other than hydrogen. So, Bohr's success to explain hydrogen spectrum only, okay? But another element, he failed to explain their spectrum. Number 2, Bohr considered the electron as a material particle only, okay? He dealt with the electron as a material, okay? And ignored the wave properties of electron, okay? Number 3, he was sure that the speed and location of electron can be determined at the same time. But this is practically impossible because apparatus used in measurement will change either the location or the speed of the electron. So we can't determine the speed and the location of the electron at the same time. Number 4, he considered the atom to be planar, okay, while the atom is expected to have 3 dimensions. After Bohr's, okay, we have a modern atomic theory. The modern atomic theory is based on some essential modification in Bohr's model. The most important modifications are the following. Number 1, the dual nature of electron. Number 2, the Heisenberg uncertainty principle. Number 3, finding the mathematical expression which describes both the wave motion of the electron and its shape and energy. Okay, thank you. Thank you, grade 11. Okay.